right, so in this video, we're going to focus on how the equation will change the graph. Now that we know these base functions, these are our starting points, and we do need to know the details of those graphs. Then we're going to talk about, okay, well, what if we change the equation a little? What effect does that have on the graph? All right, so if we replace f of x, in other words, the equation that we have, with f of x plus c. So what you're doing is you're using x plus c where x was. Then what that does is that shifts the graph c units to the left. Now I know when it says plus, that makes you think of right, but when in this case, it's the opposite. So we can kind of look at this in the same, at the same time we look at the one below. If you replace x with x minus c, now you're going c units to the right. So the left and right are kind of the opposite of the sign that you would think. When it's plus, it's to the left. When it's minus, it's to the right. So what does that mean? Let's look at these examples. Let's say I started with this graph here, the blue f of x. That looks kind of like which one? Looks kind of like the cube root, doesn't it? And if I were to replace that with f of x plus 1, that would mean I would move it one space to the right. So here where there was a 0, 0, now it's going to be negative 1, 0. Here where there was a 1, 1, now it's going to be a 0, 1. Here where there was a negative 1, negative 1, now it's going to be negative 2, negative 1. And so that's how we will do it. We will take the points that we know and we will shift them the direction that was indicated. So the example here for the shifting to the right, if I start with y equals x squared, which we should know what that looks like. And again, the specific points are not too tough. 0, 0, 1, 1, 2, 4, at least that much. And then just mirror them over. Right? If I were to replace that with x minus 3 in parentheses squared, so see where there was an x, now there's an x minus 3. That means move the whole thing 3 to the right. So take that vertex, 1, 2, 3. Take that 1, 1, 2, 3. Take the other one, 1, 2, 3. And the 2, 4, 2, 4, 1, 2, 3. And the negative 2, 4, 1, 2, 3. And then I can draw that parabola again. So that's what a left-right shift looks like. We could also do an up-down shift. And so the difference, how to identify the difference between an up-down and a left-right is the left and the right, the plus c or minus c was in with the x, whereas up and down, the plus c or the minus c comes after the whole equation. So it's kind of like you take your equation and then you add a number to it. That's what makes it go up. Or you take your equation and you subtract a number. That's what makes it go down. So I think kind of the examples we have here, again, here's another cube root looking function. And if I replace it with f of x plus 1, see the difference. Go back up to this first one. It was f of x plus 1. The x plus 1 was inside where the x usually goes. And down here, it's f of x, the whole equation, plus 1. The plus 1 is on the outside. That's what shifted it up. And so the points that we knew about all got shifted up 1 and redraw the shape. In this case, I actually had an equation, 3x squared. That would be this red function. And if I have 3x squared minus 8, I'm just going to take the points I know and shift them down 8, down 8, down 8, and redraw the function. So up, down, left, right. We also have reflecting. Okay? So there's basically two different places we're going to reflect across the x-axis or across the y-axis. How do we tell what's happening? So again, if I take my function and I multiply the whole thing by a negative, so this is negative times your equation. That's going to reflect it across the x-axis. So if I started with y equals the square root of x, and then I'm going to graph it as y equals the negative square root of x, I take these, and again, here's a 0, 0, 1, 1, 4, 2. And when I reflect across the x-axis, it just changes it from 1 positive 1 to 1 negative 1. 4 positive 2 to 4 negative 2. So it changes the sign on the y. That should make sense because look what you did right here. You changed the sign of the y. The difference, how do I know when I'm reflecting across the y-axis? In that case, I'm changing the sign on the x. So I would go from a positive x to a negative x. So that would look like y equals the square root of x here, and y equals the square root of negative x here. So the difference is the negative goes in with the x inside the equation. That tells you to reflect across the y-axis. So now the 1, 1 is now negative 1, 1, and the 4, 2 is now negative 4, 2. Okay. And then last but not least, we have these stretches and these stretch and shrink. And stretch and shrink, stretch and compress, I guess, is kind of a little bit harder to visualize, but the idea is generally that if you start with this solid blue, you're not going to move pick the whole thing up, every single piece, and move the whole thing up or down. Instead, you're going to just it's almost like you're going to take your hand and pull this part up, leaving this part kind of still down here, or push that part down, leaving the rest of it the same. So it's like stretching taffy or compressing it, right? And how that's happening is because you're multiplying by a c, multiplying by a number. So if you multiply the equation by a number bigger than 1, it's going to make the y values bigger by that amount, right? So if you started with an f of x and you said, now I have 2f of x, every single y value is going to be twice what it used to be. But if you multiply it by a number that's between 0 and 1, that's going to shrink it. It's going to compress it down. So if I had multiplied it by 1/2, now every y value is half of what it used to be. Okay. That would be for vertical, and horizontal is the same idea, only the multiplying is now multiplying the x instead of multiplying the y. So great way to see this is, here's my standard parabola x squared. If I put inside where the x was, now I multiply it by a number. If that number is bigger than 1, it's going to make, it's going to make the graph more compressed. Again, like you were pushing it in from the sides. Whereas if you multiply it by a number that's between 0 and 1, like here, it's going to make it more stretched. So it's like you're pulling it out from the sides. Okay. Now, I know there's a lot of transformations that we just went over. The good news is these first 4, up, down, left, right, I think are pretty straightforward. And the reflect is also not too complicated, as long as you remember, if you put the negative in front of the equation, flips across the x-axis, changes the sign of the y. Or if you put it in front of the x, then it changes the sign on the x. Those 6 are pretty straightforward. The compressing and stretching is a little bit more complicated because you have to look at what's happening with the value of the number you're multiplying by. I would strongly advise you, before you do anything else in this lesson, is to, before you watch the next video, is to make yourself some flashcards. I know it seems like it's an old school thing to do, but it is such a great idea when you have to have some things kind of committed to memory, or even just make yourself one card where you summarize the different translations so that you could use that as a reference while you're trying to do your homework or the rest of the videos, until it becomes something that you have memorized as second nature. I would also advise you to do the same thing for the toolkit functions. You need to know what those look like. You need to know the details of those. So you probably want to do something now to get those as an easy reference rather than having to flip back and forth through pages of notes while you're trying to take notes. So do that now, and then go ahead and watch the next video.